Hello everyone. Alright, so today's lesson is on learning target 11, exponential functions. You're going to go ahead and pause right here and make sure you copy this down. LT11, exponential functions. Make sure you read the learning objectives. I will go over them as we learn them and remind ourselves that yes, we did cover that. Okay, so make sure you read those. Pause that right now. Read this. Make sure you have a pen and pencil. Make sure you're ready to take notes. Alright, welcome back. So you have read those, and I'm going to move on. Here are the four different types of exponential functions. This is what they look like. You remember how I told you to make sure you knew and you read what the learning targets were? Learning objective. Bam! Students will recognize a graph of an exponential function. Here are the four types again. Here's what I want you to do. On your paper, I want you to draw them. Super important. Here's how we're going to draw them. First, it starts kind of looking like a line, and then it shoots upward. The other one, it's kind of starts like a line and shoots downward. Next one shoots upward and ends up going kind of like a line. Next one shoots downward and levels out like a line. Those are the four different types of exponential functions. Bam! We already covered one. Alright, now we're going to look at Desmos and see how that relates. Because the next thing we want to do is we want to recognize an exponential function. What that means is, you know how you had a line? You would say, oh, that's an equation of a line. Or we had a quadratic. Oh, that's a quadratic. I recognize that. Now we're going to recognize an exponential function. Okay, so here's Desmos. And lucky for you, I already have an idea of what an exponential function looks like. So I'm going to give you a head start. I'm going to put sliders on it. And notice right away it starts off looking like a line. That's not what we want, right? We want it to look like one of these. So that's not going to work. So what that means is that A and cannot be 1 and B cannot be 1. Right? Because if I have both A equal 1 and B equal 1, I get a straight line. So the first thing I want to do is I want to take a note of that. I cannot have both A equal 1 and B equal 1. And there's my first note. And by the way, remember that I started off with this. This is the general form of an exponential function. Remember, just like we had that y equals 3x or whatever it was, right? That's our general form of an exponential function. So we're looking for something where a is some number, b is some number, and x is going to be the number we plug in. So if we make a graph, we're going to plug in, they're going to give us this, they're going to give us this, and x is what we're going to change, and then y is what we're going to get when we change x. So, okay, so going back to Desmos, we know that A cannot be 1 and B cannot be 1. Let's take a look at B. So let's see what happens if we just change B. Oh my goodness, so much happens. So much happens. Oh, there's an exponential function. And that's, oh, where does it fall apart? Alright, so at some point it is an exponential function, and somewhere along the line it changes. Of course at B1, B equals 1. So, oh wait a minute, so B can't be less than 1. Oh wait a minute, it can be, can't, okay, okay, there it is. There it is, that's fine, that's good. So B can't be 0, and B can't be less than 1, less than 0. B can't, because we want a curve, we want a solid curve. None of this works. These are not exponential functions. We already recognize the graph. This is not the graph of it. So it turns out that B has to be greater than, B can't be 0, but B can be between 0 and 1, but it just can't be 0. So it's got to be greater than 0, but not 1. It's got to be greater than 0, but not 1. B cannot be, B has to be greater than 0, but it cannot be 1. So let's put that down over here. B has to be greater than 0. So this is really the only way that we can put it. We can't really say B can be between 0 and 1. It can be, but it can't be 1, and it can also be greater than 1. So we're just going to say, you know what, it looks like B can be pretty much anything, but it cannot be 1, and it has to be greater than 0. So that means if I were to make a number line of it, B can be anything greater than 1, but over here at 1 it falls apart. So it's kind of like got a hole in it right there. It's kind of like that. Don't worry about this too much. That was just kind of trying to figure out what it would look like. But this is important. It can't be 1, and it's got to be greater than 0. It cannot be, so we can't have 3 times negative 2 to the something power. And why? Because when I do, I don't get an exponential function. Okay, now let's just double check 1. Let's see if there's any other place it falls apart at 1 for A. So let's make it an exponential function. There it is, a nice pretty curve. Is there anything else where A falls apart besides that 1? Just double check. Oh, what about right there? So A can't be 0 either, because it becomes a straight line as well. What does that mean? Well, so if A was 0, I'd have 0 times something. Well, that's just 0, so that's y equals 0. It's a straight line. Here's y, here's x. When y equals 0, I've got this straight line right there, because this is 1, this is 2, this is 0. So that's why it can't be. I need it to be a curve. That's the whole idea of an exponential function. Okay, so it falls apart there. So I think we have everything we need. A can be anything, but it can't be 0, it can't be 1. B can't be 0, can't be 1, but it also has to be great. It has to be a positive number. B has to be positive. What about A? Does A have to be positive? No, it does not. It's still a curve. It's a different kind of curve, but it's still a curve. So it's still an exponential function. All right, so let's put this together. First, we're going to look at this function. What does this function look like? Okay, so we're going to move these around. Oh, there it is. So A has to be some number greater than 0, and B has to be some number greater than 1, because otherwise it turns like that. So B has to be greater than 1, A has to be greater than 0. So some example of these that will give us this kind of curve would be y equals 3 times, let's say, 2 to the x power. And that's not the same thing as y to this x. That is not the same thing, because you're going to have to use exponents first and then multiply times 3. So you're going to have, you could have y equals 2 to the x. Anything like that is going to give you this function here. Okay, so let's look at the yellow function. Okay, basically this function is y equals 2 to the x. A is 1, so it's almost like it's not really there. And then we have 2 as your b, and then so 2 to the x. So let's see what happens when we change a. Okay, a just keeps getting taller and taller and raises higher and faster. And there we go. So if a is negative, if a is less than 0, that's going to give us that function there, and that's this one here. Yep. Alright, so a has to be less than 0 and b is greater than 1. Let me just make sure. B greater than 1. Here's 1. Yep. So b is greater than 1. Okay, so anything like y equals 1/2. Oh, less than 0. So negative, yeah, 1/2, but negative 1/2. Or let's just make it a whole number just for fun. Negative 2 times, and b has to be greater than 1, so like 3 to the x power. And again, it's not negative 6 to the x. And a could be, so it actually can't be 1. Okay, and there are a couple of examples that will give us this kind of function, this kind of graph. Did you copy that down? Okay, here's the third type of exponential function. Alright, so we went from this one and we want it to go to that. Okay, so if I change this one, nope. Okay, what if I change this one? Nope. And is that what we want? There it is. Alright, so B has to be, so it looks like A is, well, let's look at just B. B has to be, oop, falls apart there. So B has to be between 0. B has to be between 0 and 1. B has to be between 0 and 1. B has to be between 0 and 1. What about A? Does A make a difference? Alright, so we have our function there. So A has to just not be 0. And it has to be, well, it has to be less than 0. So A has to be less than 0. And that's going to give us that function. Here would be 1. Let's see, A is less than 0. So we have y equals AB to the x. So A has to be less than 0, negative 3. And then B has to be a fraction. Y could be negative 1/5, but B still has to be a positive fraction. Okay? The only thing that matters is that this has to be negative, and this has to be a fraction, a positive fraction between 0 and 1. Okay? Alright, and then the last one, we want it to be start way up high and then level off. Start up high and level off. So I'm going to change this one. Nope. So way up high. There we go. Way up high and level off. So A has to be between 0. Alright, just greater than 0. So A has to be greater than 0. And B has to be, A has to be greater than 0. Alright, so A has to be greater than 0. I'm going to just make it 1. And where does it fall apart at? So this is what we want there. So it falls apart at when B is 1. And it falls apart when B is 0. So B has to be between 0 and 1. B has to be between 0 and 1. B has to be between 0 and 1. So it looks like that's the same, but in this case, these are different. Okay, so an example of that would be, again, y equals AB to the x. So y equals, A has to be greater than 0, so it could be 1. It could even be 1/2, that's greater than 0. And B has to be between 0 and 1, so this also has to be a fraction. So this one has to be a fraction, and this one just has to be greater than 0. Just has to be greater than 0. So 1/2, it could be y equals 5 times 1/4 to the x. Okay, just has to be greater than 0. Alright, and those are our functions. We're going to put them all together and name them. This is the most important one, exponential growth. I'm going to make it all nice and neat in a second. Okay, and this is the next most important one. This is exponential decay. These are the ones we use the most. We use this for aging trees, fossils, things like that. We use this big thing we'd use that for right now, especially disease, COVID, etc. This one here would be a really good picture to take a picture of or to copy. And then go ahead and then I'll pause it and then I'll show you the other one you need. It's funny because it actually took me forever to find the other kind, and it was on Excel. So yeah, on IXL it kind of gives you an idea like, wait a minute, which one am I going to need? And so notice this number out here we didn't cover. This is just like the parent function. Basically it's going to drop it down by 6. So down here, so it would be, it usually goes down to 0, but if you drop it down by 6, it's going to be one of these, either this one or this one, right? And then we know it's one of these kinds of functions here. So remember, what would that be? We're really looking for, the big difference is that this b value has to be a fraction. The b value should be a fraction. And we know we're going to drop it down by 6, the b value needs to be a fraction. So it's got to be this one. Okay? On the next video, we're going to go to where these come from, how are we going to use them, why they're important, etc., and the domain range and that whole bit. So this was just, it looks like the beginning, right here, the first two up here. Okay?